Something big is happening with a comet right now, and I want to explain exactly what James Webb found, why it matters, and what scientists are actually saying about it. The comet is called C/2024G3 ATLAS. Most people are calling it 3I/ATLAS, but let me clear that up first. The 3I name is actually being used for a different object, an interstellar object spotted in 2025. C/2024 G3. ATLAS is a comet from our own solar system. It became one of the brightest comets seen in years. So when you hear 3I/ATLAS in headlines, it helps to know there's some confusion in naming going on. I'll explain both, because the Webb data touches on connected ideas about what these objects are made of and where they come from. Let me start simple. A comet is basically a frozen ball of rock, ice, and dust. It travels through space. When it gets close to the sun, the ice heats up and turns to gas. That gas forms a glowing cloud around the comet. It also creates the tail you can see from Earth. That's the basic version. Now let me add some detail. C/2024G3. ATLAS came incredibly close to the Sun in January 2025. Scientists call that a perihelion, the closest point a comet gets to the Sun in its orbit. This comet got very, very close. We're talking closer than Mercury. The Sun's heat was intense at that distance. Most comets that get this close either fall apart completely or get seriously damaged. This one survived, at least partially. That alone made scientists want to study it fast. What I find interesting is that comets like this don't come back often. Some have orbits lasting thousands of years. This one might be on a path that takes it back out into deep space, never to return in any of our lifetimes. So Webb had a short window to look at it. And Webb did look at it. Now here's where the Webb data gets interesting. James Webb Space Telescope is designed to see things in infrared light. That's basically heat light our eyes can't see. When Webb points at a comet, it can detect the specific chemicals coming off it. Different chemicals release different light signatures. It's like a fingerprint. Webb reads those fingerprints and tells scientists what the comet is actually made of. What did Webb find? The early data showed something that caught scientists' attention. The comet was releasing gases that suggested an unusually rich mix of material. We're talking about things like carbon dioxide, carbon monoxide, water ice, and complex organic molecules. Organic molecules just means carbon-based chemistry, the same kind of building blocks found in living things on Earth. I want to be careful here. Finding organic molecules on a comet does not mean life. It means chemistry. But it's still significant. The reason it's significant is this. Scientists think comets may have played a role in delivering water and organic material to early Earth billions of years ago. This is called the panspermia hypothesis in some circles, but more accurately, it's part of the theory of how Earth's oceans and chemistry got started. If comets like ATLAS carry a rich load of these molecules, it adds weight to that theory. The current theory says comets bombarded early Earth and brought the raw ingredients for life. Webb's findings are consistent with that. Now let me add another layer. What made scientists look even more carefully at this comet was its brightness. It became bright enough to see with the naked eye in parts of the southern hemisphere. That's rare. Comets are usually faint smudges even with a telescope. When one gets this bright, it means the comet is either very large or releasing an unusually large amount of gas and dust, or both. In the case of C/2024G3 ATLAS, scientists believe it was releasing enormous amounts of material as it passed the Sun. To me, This is where things get really interesting. The more material a comet releases, the more Webb can detect. It's like the comet is basically doing the work for the telescope. A comet that releases a lot of gas gives Webb more fingerprints to read. So this wasn't just a bright comet, it was a scientifically generous one. Now let me bring in the 3I/Atlas connection, because I want to be clear about this. In 2025, astronomers detected what appears to be a third interstellar object passing through our solar system. The first was Oumuamua in 2017. The second was Borisov in 2019. This potential third one is being tracked right now. Some sources started using the name 3I/Atlas because the Atlas telescope network helped spot it. That's a sky survey system, asteroid terrestrial impact last alert system, that scans the sky for moving objects. So you have two different things happening at once. C/2024G. 3. Atlas, the bright solar system comet Webb studied, and the possible 3I interstellar object that the Atlas network detected. The headlines mix them up. I can see why people got confused. The interstellar object story is important on its own. If confirmed as interstellar, meaning it came from outside our solar system, it becomes the third known visitor from another star system. That's remarkable. Oumuamua was strange because it had an unusual shape and weird movement. Borisov was more like a normal comet. If this new object is real and confirmed, scientists want to know, what's it made of? Where did it come from? Does it match the chemistry of our solar system, or is it different? Webb would be an obvious tool to study such an object. That's likely where the Webb revealed something about 3I/Atlas headlines come from. The idea that Webb could or would study this object and reveal its composition is scientifically exciting. Whether that data has been fully published and confirmed as of the time you're watching this, you should check NASA's official site for the latest, because this is a fast-moving area of research. Let me go back to what is confirmed. Webb has proven it can read the chemistry of comets with incredible detail. That's confirmed. The telescope picked up complex molecules in other comets before this. It did the same with Atlas-related observations. The data on what comets are made of keeps getting richer and more detailed every time Webb looks. One thing Webb confirmed earlier in its mission was the presence of carbon dioxide in a comet in a way that hadn't been detected so clearly before. It also confirmed water in other space objects. Each of these findings adds to a bigger picture. The picture is this. The raw material for chemistry, for life, seems to be spread widely through space. It's not rare. It's not special to Earth. It might be everywhere. The way I understand it, that's one of the most important things Webb keeps confirming. Not that life is everywhere, but that the ingredients are. That's a different thing, but still a big thing. Now let me explain what makes Webb uniquely good at this kind of work. The telescope sits at a point in space called L2, about 1.5 million kilometers from Earth, on the opposite side from the Sun. It's cold there. Cold is important because Webb needs to detect infrared heat signals. If the telescope itself were warm, its own heat would drown out the signals it's trying to read. Being cold and in deep space means Webb can detect incredibly faint heat signals from distant objects, including comets. Webb also has a mirror that's much bigger than Hubble's. Bigger mirror means it collects more light. More light means more detail. The combination of cold, large mirror, and infrared sensors makes Webb the best tool humanity has ever built for reading the chemistry of space objects. I also want to mention something about timing. Comets are moving fast. Webb has to be pointed correctly, at the right time, to catch a comet as it passes. Scientists had to plan this carefully. The window for observing C/2024G3 near perihelion was short. Webb had to be ready. The fact that it got useful data in that window shows how well the mission is being managed. Some scientists suggest the comet may have broken apart partially after its close pass with the Sun. Comets do this sometimes. The heat and gravitational pull of the Sun can tear pieces off, or even break a comet into multiple fragments. If Atlas broke apart, that actually helps science in some ways. Exposed fresh interior material releases even more chemical information. It's like cutting open a sample to see what's inside. Some scientists suggest this may have contributed to the unusually rich release of material Webb detected. Now write for this. Let me also explain why this matters for future missions. There's ongoing discussion, and some planning, around the idea of sending a spacecraft to intercept a comet or interstellar object. The European Space Agency has a mission called Comet Interceptor. It's designed to fly to a new, pristine comet, one that's never been near the Sun before, or potentially an interstellar visitor. The idea is to get up close and collect physical data, not just remote observations. Webb can tell us what's there from a distance. A physical mission would bring that science even closer. The data Webb collects now helps decide which objects are worth chasing. If Webb spots an interstellar object with unexpected chemistry, that jumps to the top of the list. To me, that's the real chain here. Webb observes. Webb finds something interesting. Scientists plan a closer mission. Humanity learns more. Slowly, step by step, we map what's actually out there. I also want to be honest about what we don't know yet. The full analysis of Webb's data on the Atlas observations takes time. Scientists collect the raw data. Then they process it. Then they analyze it. Then they write papers. Then those papers get checked by other scientists. That process takes months, sometimes longer. So what I'm describing is based on the early results and what has been reported publicly. The deeper analysis may confirm everything, add new details, or occasionally correct an early reading. That's how science works. I think that's worth saying clearly. What I found particularly interesting when looking into this is how much overlap there is between the comet chemistry story and the origin of life question. These aren't separate topics. They're connected. Every time Webb finds complex organic molecules in space, it strengthens the idea that Earth wasn't special in getting those ingredients. It just happened to be in the right place, at the right temperature, with water already present, for those ingredients to combine into something alive. That doesn't make life common across the universe. It doesn't make it rare either. It just says the supply chain for life's ingredients seems to exist throughout space. What happens next, whether those ingredients actually become life somewhere, is a separate question, one we don't have the answer to yet. There's another detail I want to add about the Atlas survey network specifically, because I think people underestimate how important it is. Atlas is not a single telescope. It's a network of telescopes scanning the whole sky repeatedly. Its job is to find moving objects, things that shift position from night to night, comets, asteroids, and potentially interstellar visitors. It's one of the main early warning systems we have. It spotted this comet months before it got close to the Sun, which gave scientists time to prepare Webb and other telescopes for observations. Without systems like Atlas doing the scanning work, we'd miss most of these objects. Webb is powerful, but it only looks where it's pointed. Atlas figures out where to point. The two systems work together, even though they're completely different tools. I think that collaboration between different types of instruments is one of the most underappreciated parts of modern space science. Now let me bring this to a clear landing. Here's what I understand after going through all of this. C/2024G 3IATLAS was a genuinely significant comet. It got extremely close to the Sun, survived, became one of the brightest comets seen in years, and gave Webb an opportunity to study its chemistry in detail. What Webb found, complex organic molecules, carbon-based chemistry, water-related signals, fits into the bigger picture that the ingredients for life are not rare in the universe. Separately, there's excitement around a possible third interstellar object, also connected to the Atlas name, that may be passing through our solar system. If confirmed and studied by Webb, that could become one of the biggest astronomical stories in years. Whether that data is fully published by now depends on timing. Check NASA and ESA's current releases. The headline, "NASA confirmed James Webb revealed something incredible," is not false, but it's compressed. The reality is a layered set of discoveries, each building on the last, using different tools, over a period of months. That's how real science usually looks. So for me, the main thing is this. Webb isn't just taking pretty pictures, it's reading the chemistry of the universe. Every comet it studies, every molecule it finds, adds to a map of what space is actually made of. And that map keeps suggesting the same thing. The building blocks of life are out there, spread across space, in places we never expected to find them. That, to me, is worth paying attention to.